This is example 7.2 from Discovering Design with Chemistry. A student measures out 15.6 grams of magnesium chloride. How many moles does he have? And then after that, we will figure out how many molecules of magnesium chloride does he have. So the first step we're going to do is let's build what magnesium chloride looks like in its chemical formula. So magnesium is here and chlorine is here. So magnesium is going to have a +2 charge and chlorine is going to have a -1 charge. And so because we have a +2 and a -1, when those switch places, we'll end up with magnesium chloride, like that. Okay, and we know that, well, this would be useful to think of later. We know that the unit, when we're talking about chemical things, is a molecule. So this would be one molecule. Okay, so now let's, I guess I can't backspace that arrow. Okay, so let's talk about how many grams is in 1 molecule of magnesium chloride. To do this, we need to add up this number right here and this number right here, but we have to make sure that we use the right amount of each. So we have 1 magnesium, so that's 24.31, and then we have 2 chlorine, so we have to multiply 2 times 35.45. Now remember, when we do these, we are really adding 35.45 times 2. What we're really doing is we're adding that to itself 2 times, so we only have to worry about the rules of adding significant figures. And so since 24.31 is to the 100th place, and since 35.45 is to the 100th place, our answer is going to be to the 100th place. So this is 95.21, and that's AMU. But that number also means that if we have 1 mole of magnesium chloride, or MgCl2, we would need 95.21 grams worth of magnesium chloride to make 1 mole. So that helps us out because they have told us how many grams we have, and we know that, well, 15 is a lot less than 95, so we have less than a mole of magnesium chloride, but we can use this thing that we just figured out as a conversion relationship. So we can take our 15.6 grams and then we can multiply it by what we have up here. So grams will need to go on the bottom and moles will need to go on the top. And that way the grams will cancel when we add them in. Okay, so let's use this. So 1 mole is the same as 95.21 grams. And I could write of MgCl2, but I am probably not going to write that every time I do this. Okay, so this time we actually do have to pay attention to the rules of, oops, wrong one, to the rules of significant figures for multiplying and dividing, because now we're dividing numbers that are not exact. So 15.6 has 3 significant digits and 95.21 has 4. So we're limited to 3 significant digits. So that means we have 164 thousandths, or 0.164 moles MgCl2. All right, so this is the answer to our first question, which makes sense. We had 15 grams. A whole mole is 95.21 grams. 15 is much smaller than 95, so we should have a lot less than 1 mole, a small fraction of a mole, which is what we have. All right, the second question asks how many molecules of magnesium chloride does he have? So let me put my first answer up here by the first question. Okay, so remember that a mole is 6.02 times 10 to the 23rd. If I have a mole of eggs, I have 6.02 times 10 to the 23rd eggs. If I have a mole of flowers, I have 6.02 times 10 to the 23rd flowers. If I have a mole of MgCl2, the unit that is a molecule, I have 6.02 times 10 to the 23rd molecules of ClO2. So, I'm sorry, of MgCl2. So 1 mole equals 6.02 times 10 to the 23rd molecules of whatever. So in this case, we can use this again like a relationship. We have this many moles of MgCl2, and if we multiply it by how many moles are the same as a molecule, because these two are equal, it's like multiplying by 1. It's just a conversion relationship. I have 1 mole for every 6.02 times 10 to the 23rd molecules. And then my moles will cancel out, and I'll be left with molecules. So 0.164 times 6.02 times 10 to the 23rd. I could have used the EXP button, but sometimes it doesn't work. Let's see if this will change it. There we go. Okay. So my answer is, now remember again, we have 3 significant digits here, and so we have to worry about this one too. That's another 3 significant digits. So our answer has to have 3 significant digits. So that's all we're going to keep from this. So 9.87 times 10 to the 22. Oh, goodness. 0.87 times 10 to the 22. That's how many molecules we have of magnesium chloride in our sample. This second part is probably something you will only do in this chapter, but this first part is very important to upcoming chapters. So make sure that you're comfortable with figuring out how many moles you have if you're given the number of grams or the amount of grams. If that confused you, work through it again. Make sure you get the same answer, and then try some of the practice problems before you move on to the next section.